Okay, so in this video we're going to be looking at Unit 6, Lesson 3. It has to do with power. It can be found on page 263 to 264. Okay, so power is just a little step up from what we've been doing. Power is the work done divided by the time that it takes to do that work. So if you perform work, which is a force times distance, so work is force times distance. So if you do that work, then you're exerting power. Now how much power you are exerting depends on the time. So it's work divided by time. Just like speed is distance divided by time, power is work divided by time. So speed is the rate at which you cover that distance, and power is the rate at which you do work. So for example, you have to do a certain amount of work to pull yourself up the rope in gym class. Okay, you know, pull, yank, get to the top. So it takes a certain amount of work to do that. Now, the speed at which you can do that determines how much power you have. Okay? So the units for power is watts. Okay, so you might have heard of the term kilowatt. A kilowatt is merely 1,000 watts, like a kilogram is 1,000 grams. And the symbol we use for watts is W. Okay, so work gets the units J for joules. Power gets the unit W for watts. Now let's look at this a little bit more. If power equals work divided by time, and work equals force multiplied by distance or displacement, then a glass of water that weighs 2 newtons is lifted 0.5 meters. Question is, how much work do you do? So work is force times distance. So force times distance. Alright, so you know how we always, what we've been doing is saying, okay, we have our mass, now we need our force. And our force is Fg, which is our weight, and they already gave you Fg. So here, that 2 newtons, they just knocked out a step for you. So work equals force times distance. Alright, so work equals 2 times 0.5. So you just did 1 joule of work. Well, good for you. You did 1 joule of work. But how much power did you just exert? Well, if it only took you 1 second to do that, and power equals work divided by time, then you did 1 joule of work in 1 second. So you just did 1 watt of power. Now, if it had taken you 2 seconds, let's just say hypothetically, it took you 2 seconds, then power equals work divided by time, which would equal 1 divided by 2. So then that would be half a watt of power. So the longer it takes you to do something, the less power you have. Okay. Now, an electric motor lifts an elevator 9 meters in 15 seconds. by exerting an upward force of 1.2 times 10 to the 4th newtons. What power does the motor produce in watts? And then in your book, I added this in because this is how they ask it in the book. What power does the motor produce in kilowatts? Alright, so we're looking for power. And we know power equals work divided by time. Well, we know 15 seconds is our time. But it doesn't anywhere tell us what our work was. But it does tell us that we went 9 meters, so that's our distance, and we exerted a force of 1.2 times 10 to the 4th. Okay, so that's our force. Now, we can simplify this down. Some of you guys really hate scientific notation, so I'll take it out. Alright, because you have a 4 here, that means you're going to be moving the decimal place over 4 spaces. So you have 1.2, right? So it's 1, 2, 3, 4. So that is 12,000. So you have 12,000 newtons of force. Alright, so you know time, you know distance, you know force. Well, if you know force and distance, then you know work. Because work is force times distance, and all you gotta do is divide that by time. Well, you have all 3 of those parts. So you have 12,000 newtons times the distance, which was 9 meters, divided by the 15 seconds it took to get there. So if you sit down with your calculator, which I'm going to do right now, 12,000 times 9 divided by 15 equals 7,200. And that is watts, 7,200 watts. Now, for the second part of the question, it deals with kilowatts. Now, 1 kilowatt is 1,000 watts. Alright, so if we have 7,200 or 7,200 watts, and 1 kilowatt is 1,000 watts, then just like we did earlier in the year, watts can cancel out, and you end up with 7.2 kilowatts. So that's your kilowatts, and that's your watts. So it's just a small step up from what we've been doing with power. Sorry, what we've been doing with work. We're just taking work and we're dividing by time, and that gives us power.